The Earth is not flat. This statement might seem like common sense to many, but it's a topic that has surprisingly gained traction in recent years. The flat Earth theory, which suggests that our planet is a flat disk rather than a sphere, has found new life in the age of the internet. Despite overwhelming evidence to the contrary, some people have started to question the shape of our world. This might seem obvious, but the flat Earth theory has resurfaced in recent years. It's a phenomenon that has puzzled scientists, educators, and rational thinkers alike. How could such an outdated and debunked idea make a comeback in the modern era? The answer lies in the way information is shared and consumed today. Social media platforms and online communities have made it easier for fringe theories to spread and gain followers. It's important to approach this topic with critical thinking. We must ask ourselves why people are drawn to such theories and what it says about our society. Are we becoming more skeptical of established knowledge, or is there a deeper issue at play? By examining the reasons behind the resurgence of the flat Earth theory, we can better understand the importance of scientific literacy and critical thinking in today's world. We need to rely on evidence and scientific understanding to explain our world. Science is not just a collection of facts, it's a method of inquiry that helps us make sense of the universe. Through observation, experimentation, and analysis, scientists have been able to demonstrate the spherical nature of the Earth. From the way ships disappear over the horizon to the way we experience time zones, the evidence is all around us. This is not just about the shape of the Earth, it's about how we evaluate information and form our beliefs. In an age where misinformation can spread like wildfire, it's crucial to develop the skills needed to discern fact from fiction. By understanding the scientific method and the principles of evidence-based reasoning, we can better navigate the complex landscape of information that surrounds us. It's about how we evaluate information and form our beliefs. Our beliefs shape our actions and decisions, and in turn, they shape the world we live in. When we base our beliefs on sound evidence and logical reasoning, we contribute to a more informed and rational society. Conversely, when we accept unfounded theories and reject established knowledge, we risk undermining the progress that has been made through centuries of scientific inquiry. The evidence for a spherical Earth is overwhelming. From the photographs taken by astronauts in space to the way we experience day and night, the proof is undeniable. Yet it's not enough to simply present the evidence. We must also understand why it matters. The shape of the Earth is a fundamental aspect of our understanding of the world, and it has implications for everything from navigation to climate science. We can observe it through simple experiments. For example, by measuring the angle of shadows at different locations, we can calculate the curvature of the Earth. These experiments are not just educational, they are empowering. They show us that we don't have to take scientific claims on faith, we can test them for ourselves and see the results with our own eyes. We can understand it through established scientific principles. The laws of physics, the principles of geometry, and the methods of scientific inquiry all point to the same conclusion. The Earth is a sphere. By learning about these principles, we gain a deeper appreciation for the beauty and complexity of the natural world. We also develop the tools needed to question and understand the world around us. Let's explore the evidence together. By embarking on this journey of discovery, we can strengthen our understanding of the world and our place in it. We can also foster a sense of curiosity and wonder that drives us to keep learning and questioning. So, let's dive into the evidence, conduct experiments, and engage in thoughtful discussions. Together we can uncover the truth and appreciate the incredible world we live in. One of the simplest ways to prove the Earth is round is by observing a ship sailing towards the horizon. This simple yet profound observation has been a cornerstone of our understanding of the Earth's shape for centuries. As the ship moves further away, it provides a visual demonstration of the Earth's curvature. If the Earth were flat, the entire ship would gradually shrink in size as it moved away. You would see the ship getting smaller and smaller, but it would remain fully visible until it was too small to see. This is because, on a flat surface, there would be no obstruction between the observer and the ship. However, this is not what we see. Instead of the ship just shrinking uniformly, something different happens. The ship begins to disappear from the bottom up, which is a crucial observation. Instead, the ship disappears hull first, with the mast remaining visible longer. This phenomenon occurs because the Earth's surface is curved. As the ship moves further away, the curvature of the Earth gradually obscures the lower parts of the ship first. This happens because the Earth's curvature obscures the hull first. the curvature acts like a barrier, hiding the lower parts of the ship from view, while the upper parts, like the mast, remain visible for a longer period. Then, the rest of the ship gradually disappears. As the ship continues to move away, more of it becomes hidden by the curvature until it completely vanishes from sight. This gradual disappearance is a clear indication of the Earth's round shape. This wouldn't happen on a flat Earth. On a flat Earth, the ship would remain fully visible, just getting smaller and smaller as it moved away. The fact that we observe the ship disappearing hull first, and then gradually vanishing, is strong evidence of the Earth's curvature. This simple experiment, which anyone can observe, provides a powerful demonstration of the Earth's roundness. The Horizon experiment is a testament to the power of observation and critical thinking. By simply watching a ship sail away, we can gather evidence that supports the scientific understanding of our world. This experiment is accessible to everyone and requires no special equipment, making it a perfect example of how science can be both simple and profound. So next time you find yourself near the ocean, take a moment to watch a ship sail towards the horizon. Remember that what you're seeing is not just a ship disappearing, but a demonstration of the Earth's curvature. It's a beautiful reminder of the wonders of our planet and the power of human curiosity. Think about sunsets. Have you ever noticed that the sun sets at different times depending on where you are? This is another piece of evidence for a spherical Earth. If the Earth were flat, the sun would set at the same time for everyone. However, because the Earth is curved, different locations rotate into and out of sunlight at different times. This difference in sunset times is a direct result of Earth's curvature. Over 2,000 years ago, a Greek scholar named Eratosthenes made a groundbreaking discovery. He calculated the Earth's circumference using nothing more than shadows and basic geometry, a feat that was astonishing for his time. Eratosthenes was the chief librarian at the Library of Alexandria, one of the most significant libraries of the ancient world. He was a man of many talents, but his most famous contribution came from a simple observation. He noticed that at noon on the summer solstice the sun cast no shadow in Siene, Egypt. This was because the sun was directly overhead. However, on the same day and at the same time, he observed that in Alexandria, which was several hundred miles to the north, the sun did cast a shadow. This difference in shadow lengths intrigued him, and led him to ponder the reason behind it. Eratosthenes realized that the only explanation for this phenomenon was the curvature of the Earth. If the Earth were flat, the sun would cast the same shadow at the same time, regardless of the location. The varying shadow lengths indicated that the Earth's surface was curved. To calculate the Earth's circumference, Eratosthenes used the distance between Syene and Alexandria, which he knew to be approximately 5,000 stadia, an ancient Greek unit of length. He measured the angle of the shadow in Alexandria to be about 7.2 degrees or 1/50th of a circle. Using basic geometry, he reasoned that if 7.2 degrees corresponded to 5,000 stadia, then 360 degrees would correspond to 50 times that distance. His calculations yielded a figure of approximately 250,000 stadia for the Earth's circumference, which is remarkably close to modern measurements. This experiment is a testament to the power of simple observations and scientific reasoning. Eratosthenes' work laid the foundation for future astronomers and geographers, proving that even with limited tools, human curiosity and intellect can unravel the mysteries of our world. Section 5. Gravity and a spherical Earth. Gravity is another key piece of evidence for a spherical Earth. Gravity pulls everything towards the center of the Earth. This inward pull is why Earth is a sphere. Think about it, if the Earth were flat, gravity would pull everything towards the center of the flat surface. This would create strange effects. For example, water would pool at the center of the Earth instead of being distributed evenly. Section 6. Circumnavigating a globe. We've all seen maps and globes showing the Earth as a sphere, but did you know that people have circumnavigated the Earth? This means they've traveled all the way around it. Circumnavigation is only possible on a spherical Earth. On a flat Earth you would eventually reach an edge, but countless explorers have sailed and flown around the globe, proving that it is indeed round. Section 7. Constellations and a round Earth. Look up at the night sky. The constellations you see depend on your location on Earth. This wouldn't be possible if the Earth were flat. On a spherical Earth, your position determines which part of the sky you see. Different parts of the Earth face different directions in space. This explains why different constellations are visible from different hemispheres. Section 8. Debunking Flat Earth Claims. Despite the overwhelming evidence, some people still cling to the Flat Earth theory. They often cite things like NASA faking images or a global conspiracy to hide the truth. These claims are easily debunked. NASA has no reason to fake images of Earth. There's no evidence of a global conspiracy. And countless independent observations and experiments confirm that the Earth is round. Section 9. Conclusion. Trusting the evidence. The Earth is not flat. The evidence is clear, consistent, and readily available to anyone willing to look for it. Don't be afraid to question, to explore, and to trust the scientific method. It's the best tool we have for understanding the universe and our place in it.